Hello, everyone, and welcome to a virtual planetarium, The Sky Tonight, part of our MOS at Home programming. My name is Janine. My pronouns are she and her, and I'll be your moderator today. That means I'll be reading some of your questions and responses, which you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. If you'd like to see captions during today's program, you can click on the closed captions button at the bottom of your screen and select show subtitles. And if you're joining us on Facebook or YouTube, we're so excited to have you here, but unfortunately, I'm unable to see your comments at this time. We're so delighted to have all of you here today as our audience. Let's meet our guide who's going to tell us what's up in the sky.
Hi, everybody. My name is Talia. I use she, her pronouns, and I will be showing you a few things that you can spot in the sky tonight. And to do that, I'm going to use a program called Stellarium, which is a free open source program. So you can download it and check this stuff out yourself if you're interested. And I have it set for 8 o'clock tonight, and we are facing south. So this is Boston at 8 o'clock tonight, and more stars than you would see in the real Boston, which of course has a light pollution issue. But we're facing south because we've got two very bright objects visible in the southern sky right now. And if you've been watching this show at all for the last couple of weeks, you probably know what they are, but go ahead and put in the Q&A if you know what they are. Put their names in there. And if you have no idea whatsoever, you can put a question mark, because it's always good to admit what we don't know. It's part of learning.
Prisha and Johanna both have lots of question marks. Chris is wondering if it's Polaris. Aaron, who's 4, thinks maybe it's Venus. Got some more question marks coming in as well.
Excellent. So Venus is the right track because these are in fact planets, these two objects here. And if you can see a planet like this with just your eyes, so no binoculars, no telescope, just your eyes, which you definitely can with these two, they're nice and bright. That either means that they are close to us, like Mars or Venus, or they're far away from us, but they're very, very big, which would be the gas giants. And that's what we're looking at here. We've got nicely paired in the southern sky right now, the two gas giants that you can see with your eyes, with no binoculars or a telescope. So the brighter of the two is the bigger and the closer, and that is the planet Jupiter. But right next to it in the sky, a bit dimmer because it's smaller and a bit farther away, about 500 million miles farther away, is the planet Saturn. So we have two gas giants in the southern sky tonight and for the next several weeks. So you don't have to, this isn't something that's only going to be tonight. It's something you can go check out at sunset for several weeks to come. And Jupiter is going to be one of the brightest things in the sky, which is going to make it nice and easy to spot. Jupiter is, even though it's almost 500 million miles away from us, it's very big and it's covered in bright reflective clouds. So it's pretty easy to spot in the sky. Saturn blends in a little bit better. It is still brighter than most of the stars around it, but it blends in a little bit better. But it will be the brightest object near Jupiter. And it's dimmer. Like I said, it is smaller. It's almost 1 billion miles away from us. But it does have a nice, big, highly reflective ring system going around it, which helps it be nice and bright. And Saturn's actually the farthest planet that we can see with just our eyes. Any further out than Saturn, you do need telescopes. And it took the invention of telescopes for us to discover the planets Uranus and Neptune. So that is Saturn and Jupiter, nice and bright and visible in the southern sky. I'm going to twist this around to the eastern sky, which are where things are rising. So things rise in the east and set in the west. So at 8 o'clock, relatively low on the horizon, we have two other bright objects in the sky. And I'm going to go ahead and tell you what one of them is by zooming into it. It is the moon. Not a super bright star or a super bright planet. That is the moon. It's almost full. It's nearly full. So you can see it's going to be very, very bright. I'm going to assume that you don't need my help finding the moon in the sky. Probably something you guys know how to find on your own. But right next to it in the sky tonight, now the moon's position does change from night to night, but rising in the east at 8 o'clock, around 8 o'clock for the next several nights and rising earlier and earlier each night, will be this red object, this sort of orangey red object that we can see next to the moon tonight. Anybody want to guess what that is?
Johanna wants to know, is the other object Mars?
Ha ha ha, yes it is. It is in fact a third planet for you to check out. It is the planet Mars. Now Mars, unlike Jupiter and Saturn, which are very, very bright in the sky because they're covered in these bright reflective clouds and they're very, very huge, Mars appears bright in our sky because it's actually pretty close to us in terms of planets. And it will have a bit of a reddish color to it. It's not going to be, you know, blood red or anything like that, but it will have a bit of a reddish tint to it. You know, we named it for, people all over the world named it for blood, for fire, for war, because it definitely does have that color to it. And it's going to be pretty bright these days. How bright it is depends on where Earth and Mars are in their orbits, whether they're closer together or farther away. They're getting pretty close together right now. So we actually, which is why we actually, at this point, we have a spacecraft on the way to Mars. Its name is Perseverance. It's on its way. It's going to arrive in February. But that is a third planet that you can check out in the sky. And again, tonight it's right next to the moon. It's not going to stay right next to the moon because the moon is going to move from night to night. And yes, you can see the program is telling you that Uranus is in the sky. I'm not going to show you how to find that one because you really can't unless you've got a big telescope and a lot of time. So, but that's 3 planets that you do not need a telescope to find, plus the moon. Never discount the moon. It's always quite beautiful. Now, those are planets. Those are not stars. They are not part of constellations. So let's talk about some constellations that are visible. And to do that, I'm going to first move us more or less straight up. Straight up is a trio of stars that we have been talking about, you know, all summer long. Most of the summer, because we call it the summer triangle. These 3 stars right here, Vega, Deneb, and Altair. Each of these stars is in its own constellation, but the 3 of them make this nice bright triangle. And then we call that triangle the summer triangle. But you notice it's not summer anymore. And it's still, this triangle is still nice and high, straight up in the sky, very easily visible in the evening. So I've always thought that calling it the summer triangle was a little bit of a misnomer because it's visible well into the fall. So this is another thing you don't have to rush out to check out. It's going to be visible for a while. But each of these 3 constellations is in, or each of these 3 stars is in its own constellation, some of which are a little bit easier and make more sense than others. So Vega here is the brightest of the 3 constellations, or the brightest of the 3 stars. It's in the smallest of the 3 constellations that make up the triangle. And I'll go ahead and put the stick figure for that constellation up there for you. What do you guys think? Who or what do you think that is supposed to represent? Go ahead and put your answer in the Q&A. Whatever you think that looks like. Don't worry about trying to get it right, because
this is my favorite game. It's trying to figure out how in the world people saw the images that they see in the sky.
Yeah, right.
I like this person who says square with a line. Another person says parallelogram. A couple people saying swan.
Swan, nice. Creativity is always good because I'm going to go ahead and tell you most of these constellations don't look like what they're supposed to be. And in this case, I'm afraid it is not a swan. This constellation is called Lyra the Liar. When I say liar, I don't mean somebody who doesn't tell the truth. I am talking about a stringed instrument which resembles a U-shaped harp. That's totally what you see there, right? U-shaped harp? Yeah, yeah, yeah. Again, a lot of these constellations don't look like what they're supposed to be, but there it is, the Lyre. It's sort of a kite-shaped constellation anchored by the very bright star Vega. So look sort of below Vega for the other main part of the constellation that's that parallelogram. And tilt your head and squint and see if you can make out a harp there. Now, Deneb is part of a totally different constellation. This one is the biggest of the 3. And this one I like because I think it actually does kind of resemble what it is supposed to be. It's made up of this long line right here going straight into the middle of the triangle. And then this sort of cross of stars right here. So here's this stick figure. Now, who or what do you think that is? Keeping in mind this one actually is a much better representation of what it is supposed to be. And if you don't want to make a guess, you can always, of course, put a question mark. That's perfectly acceptable as well.
We have a couple guesses. One is an umbrella. Another is a swan. And Jihan, who is 13, thinks maybe it's a person with long arms.
Those all are pretty good guesses. And I can see all three of those in this shape. One of them is correct, however, and that is the swan. So this constellation's name is Cygnus, and it is a swan in flight. So Deneb is the tail. Here's the body. Going into the middle of the triangle is the long neck ending in the head. And again, the swan is in flight. So it's stretching its long wings up to either side. And I always liked this constellation because I do think it kind of looks like a swan in flight. And there aren't many constellations that look like what they're supposed to be. So that's the biggest of the three triangle constellations. Lyra is the smallest of the three, which means there's just the middle one left. And that is anchored by the bright star Altair or Altair, which means eagle. And appropriately enough, it is part of the constellation Aquila the Eagle. Although again, this one's not completely crazy. I guess I can see how somebody imagined an eagle shape in it. If you sort of imagine that Altair and this star next to it are the head, like if Altair was the eye and this is the beak, there's sort of a faint body in here. There's a wing that stretches out this way, another wing that stretches out this way because the eagle is also flying, and then there's very long tail feathers. So I don't think this one is totally crazy. I think there were probably better things to call this. What would you have called this constellation if you were in charge of naming this shape? Not sure.
I want to let you know that we had another answer for the last one, which was like the shrug emoji.
Shrug emoji. Oh, I wish there had been emojis in ancient Greece and Rome, which is where we get most of our constellation lines from.
The constellation ahead of its time. Johanna thinks maybe it's a plus sign. Chris thinks a hammerhead shark would be a good one for it. Somebody else says just a weird symbol. An angel.
I like all of these. And again, this one I don't object to being an eagle. I don't think that's totally crazy. I can see an eagle shape there. So those are the three constellations of the summer triangle, which again, will be visible well into the fall, even though we call it the summer triangle. I also can never help but notice the swan and the eagle are flying directly at each other. So swan versus eagle, who do you think is going to win? I'm always very curious to see who picks what.
All right, the answers are starting to come in, and we've got several votes for eagle.
And see?
And also none.
None. Nobody's going to win this fight. See, this is just telling me that everybody severely underestimates how mean swans are. They're huge and they're evil. I don't know which of these I would pick, honestly. They're both very intimidating birds. Don't go near either of them is the moral of that story. So there you have the summer triangle at 8 o'clock, almost straight up. It's going to be edging more towards the west, western part of the sky in the early evening as the fall goes on, but it's still going to be nice and visible. And you can see those three bright stars of the triangle, even in the middle of Austin. So again, over to the south, there are our planets, Jupiter and Saturn. And also sort of over in the east, of course, we have Mars and the moon, which we were talking about earlier, but we were also just talking about the triangle. So there's the triangle. Sort of below the wing of Deneb, to the east of the triangle, there's another shape, the square right here, which we sometimes call the autumn square, because you've got the summer triangle. Here's the autumn square. It's a shape in the sky that starts to become very prominent in the fall. but it has a more famous name. It is more famously known as the Great Square of Pegasus. Now, can anybody tell me who or what was Pegasus in mythology, in Greek and Roman mythology?
Well, that answer came in quickly. 2 people already saying winged horse.
That's right. Pegasus was a flying horse, a horse with wings, and half of him is in the sky, but only half. I don't know. Fortunately, it's the front half. The square is the body of the horse. Coming off of this corner is a neck and a head. Coming off of this corner are 2 front legs, and that's it. That is all of Pegasus that there is, only the front half. And, you know, I guess, sure, the front half of a horse. I personally think I would have gone maybe some sort of sea creature with tentacles if I was in charge of naming this one, as opposed to an upside down half a flying horse. But that is exactly what it is supposed to be, Pegasus. And while we have, you know, the summer triangle stretching overhead, right now Pegasus is in the eastern half of the sky, but Pegasus is going to become more and more prominent in the sky as autumn goes on. I use Pegasus as my sort of anchor constellation for the autumn, because as autumn goes on and goes into the early winter, in the evening, right after sunset, Pegasus is more and more going to be just stretched right across the top of the sky. So the easiest part of it to find is the square. It's almost a perfect square in the sky, actually. The eye kind of gets drawn to it because it looks too regular a shape, and the eye tends to be drawn to that. So you can keep your eyes open for Pegasus to becoming more and more prominent in the sky as we head further into the autumn. I'm going to twirl us around to the north. We always like to spend some time looking at the northern sky because there's a few cool and important shapes in that, including the Big Dipper over here. 7 stars, 1, 2, 3, 4 in the bowl, 1, 2, 3 in the handle. And this is a pattern that is not actually a constellation, just like the summer triangle isn't a constellation. In this case, it is part of the constellation, which we call Ursa Major, the Great Bear. And honestly, the Dipper is the easiest part of the bear to find. So there it is, the bear. So the Big Dipper makes up about half of Ursa Major, the Great Bear, but it is the brighter half. It is the part that's easier to see. And if you're looking at this and going, bear? It's a little bit odd. It's because it is a weird looking bear. It has a very, very long tail. The story is that the bear got dragged into the sky by its tail. In the process, the tail got all stretched out, because we all know that's what happens when you pull hard enough on a bear's tail. But I'm going to show you real quick how to use the Dipper to find the North Star, because I want to take a moment and talk about how things move in the sky and why we like to focus on the northern sky. We spent a lot of shows focusing on the northern sky because of where we live on the Earth. The northern sky actually is, parts of the northern sky are always visible to us. And all you got to do is use these 2 stars at the front of the Big Dipper. They will point you directly to Polaris, the North Star. Also the end of the handle of the Little Dipper, which is also known as Ursa Minor, the little bear, who has an even longer tail. And Polaris is called the North Star because it sits almost directly above the Earth's North Pole. And the stars that sort of immediately surround it here in the northern sky are what we call circumpolar. It means going around the pole. And what it means for us is that the circumpolar sky never sets as Earth spins. And to show you what I mean, I'm going to go ahead and turn off the atmosphere, which means when the sun rises, the sky will not get bright. And I'm going to run time forward to show you what I mean, which we can do in Stellarium. So you can see the stars of the Big Dipper getting very, very low, but not setting. And I'm going to zoom out a little. You can see there's a whole chunk of northern sky that isn't going below the horizon, that is staying up at all times, even as other parts of the sky rise and set. You can see Vega is about to set, Cygnus is about to set. And so this is what we mean when we say circumpolar. And it has to do with where we live on the Earth, how far north or south we live. Where you live, east or west, doesn't really matter. It's how far north or south you are. So we are here in Boston, which is about 42 degrees north. You can see the ground getting light. That means the sun is rising, but I've turned the atmosphere off so you can still see the stars. And that means about half of the northern sky. So we're almost halfway to the North Pole. And so almost half of the northern sky is what we would call circumpolar. How much of the sky is circumpolar for you changes based on how far north or south you are. And so to prove that, I'm going to take a moment. So here you can see our latitude and longitude here in Boston. But I'm going to go ahead and change our latitude, how far north or south we are. I'm going to send us all the way to the North Pole. So here we are, we're at the North Pole, and I'm going to fast forward time again. As we look around, you'll see none of the stars are rising or setting. You can see the sun isn't actually today is staying just below the horizon today. The sun isn't actually rising at the North Pole today. It's perpetual, almost dawn. But if we look up, Polaris, the North Star, is what we call the North Star, is pretty much straight up. And the entire sky is circumpolar. You see the entirety of the northern sky all the time. And at no point do you see any of the southern sky, at least if you're at the North Pole. But we're going to jump in location again, because I can do that. I'm going to send us to the equator. 0 degrees north, 0 degrees south. So here we are, looking around. And if we look to the north, you can see there's Polaris. It is right on the northern horizon. And if I fast forward time again, you'll see there are no stars except for Polaris. If you've got a perfectly clear horizon that stay above the horizon all the time. So if you're at the equator, there's no circumpolar stars whatsoever. I can turn you around to the south and show you that the same thing holds true for the southern sky. There is no part of the southern sky that is staying above the horizon the whole time. I'm going to make one more jump. This time we're going to go to the southern hemisphere. So Boston's at about 42 degrees north. We are about to go to about 42 degrees south. So about equally far south as Boston is north. And see what it looks like. So this time, when I face the north, you'll see that none of our familiar northern stars, none of them are circumpolar. They all rise and they all set. And in fact, you can see that this is actually the bottom foot of the bear, Ursa Major. So there are stars that are very familiar to us. The Big Dipper does not rise above the horizon. If you're at 42 degrees south, you never see it. Just like there are southern stars that we never see from Boston. But that also means that if we turn and look to the south, there's a nice big chunk of the southern sky that is never setting, that is circumpolar. There is no southern pole star the way there is a northern pole star. The whole sky is sort of rotating around a point somewhere in here. But unless you're at the equator, there is always some part of the sky that is circumpolar for you that will never set. How much of it depends on how far north or south you are, and what stars you see depends if you are in the northern hemisphere or the southern hemisphere. I felt like we talk about circumpolar stars a lot, and I wanted to finally just explain exactly what that means and show you what it looks like from different places. But I'm done talking. I think we have a few moments for some questions, Janine, if there are any.
Sure. We have a question about how far is the Big Dipper?
So the Big Dipper, the stars are actually all different distances away. They happen to line up and make a dipper shape from our perspective, and I don't know exactly, I don't know off the top of my head how, on average, how far away those stars are. It's definitely at least a few dozen light years, but they're actually all different distances away from us. They're not all one distance away. In fact, that's true of all of these constellations. You know, they look like they make shapes to us, but those stars are actually very different distances away from us. And they just happen to sort of line up into those shapes that we make in the sky from our perspective here in our solar system. From other places in the Milky Way, those star patterns would not exist.
Yeah, I always think that's fun to talk about. We also have a question from Zachary Jones, which is, how long is Scorpio going to be visible for?
Scorpius is gone. The time of year for viewing Scorpius is gone. Scorpius is best viewed in the middle of summer. So Scorpius is pretty much set.
Oh, and one last one. Will Polaris ever change position in the sky in the future?
So yes, from our perspective here on the Earth. But it's not that Polaris is changing, it's that Earth is. Earth actually wobbles like a top. So if you can imagine the stem of a top, the part that you hold on to spin it, when it starts to run out of fuel and it starts to sort of wobble like this, Earth does that. It's not going to fall over like a top does, but Earth does do that. It does it very slowly over the course of about 26,000 years. So I'm going to jump us back to Boston. So right now, our northern pole is pointed at Polaris. I'm going to run time backwards because I want Vega, or forward, backwards, because I want Vega in the sky. So right now, our northern pole points to Polaris. But like I said, Earth actually wobbles like a top. And it wobbles in a circle that kind of goes like this, with Polaris and Vega at opposite ends of the circle. So it turns out that about 13,000 years ago, Vega was the North Star. And it's going to be the North Star again in another 13,000 years. So from our perspective here on Earth, yes, Polaris is going to appear to change its position in the sky. Actually, it's because Earth is doing its little wobble thing. But it is going to not be the pole star forever. And it hasn't been the pole star forever.
All right, well, I think that's about time. So thank you so much, Talia, for taking us on this tour of tonight's sky. I'll let you say goodbye.
Hi, everybody. Thank you for your questions and your observations.
Yeah, I'm sorry to those of you who I did not get to your question or comment, but thank you so much for joining us today. If you didn't get your question answered, you can always keep an eye out for us on Fridays or other days in the week. You can find out our schedule by visiting www.mos.org/mos@home or following us on our social media channels. And if you enjoyed today's presentation and would like to support more programming like this, please visit engage.mos.org/welcome in order to support mos.home and help us keep doing this wonderful programming that Talia and her cohort are in charge of, teaching us all about the night sky. And as Talia mentioned at the beginning of the show, today's program was produced using the free software that you can download called Stellarium. You can visit the website on your screen, www.stellarium.org, to download that. Thanks everyone for participating. We hope you'll join us again soon.